All right, welcome all. Today we're going to continue with our introduction to the course. Specifically, I want to cover more about dynamic allocation, arrays, tricks that we can use to understand this process a little bit more. If we're lucky, we can get a homework assignment out the door, but past experience has said that we won't get one out yet. Now, where we left off last time was just describing dynamic allocation. The stack versus the heap. Let me get this up. That way if there's ever questions, they can chat with me. There we are. And we did some sample test code. We used this process to allocate data in the heap. And can you tell me, let's start by instantly doing a review now. Can you tell me what this is doing? This line of code, there's a lot going on, and I consider it to be one of the hardest lines of codes of the semester. Anybody remember what's happening, even if you know part of it? Has it been a long 2 days?
No. It's an address.
What's an address?
The little star thing, an address.
The little star thing. What's this called?
Pointer.
Well, no, the starry thing. What's its true name?
Asterisk.
Asterisk or asterisk?
Asterisk.
Isk. There you go. I'm just trying to save you embarrassment in a job interview. Not asterisk, it's asterisk. And when you put an asterisk next to a data type, what does it mean? It means that this is the entire data type. Oh man, he's trying to, he's got the S there. Good. I thought he left that out. Yes, the entire data type is int pointer. It is not an int, it is an int pointer. ARR is the identifier. So what kind of data does ARR hold? No, it does not hold integers. It holds an address. And you could say the address is an integer and be smart aleck about it, and you'd be correct. But I'm looking for an address. How many bits? 4 bits? Can't do much with 4 bits. 2 to the 4th is 16. A 16-bit byte memory system isn't very exciting. 2 to the 8th is 256. Now you have 256 bits, but that's usually we have more RAM than that, more addressable space. How many bits is an address? 32? 64? Could be both, depending on how it compiles. Almost all of us now are running 64-bit operating systems. What that means is the addressable space is 64 bits. But a lot of programs, if they're 32 bits, it works as assuming that it's a 32-bit OS. But if you compile it as a 64-bit mode, you will get a 64-bit address. For what we're doing here, well, a lot of us are going to see 32-bit addresses. That's fine. We're not going to need more than 4 gigabytes of address space for our programs. Are we good so far on that? All right? So we know that this holds an address. Does that address also have extra information telling us how big this array is?
It's a size, array size?
There's this array size, but does the address or does the pointer know how big the space is?
No.
Does it know if it's even valid? No. All it knows is an address. It's like if you or somebody told you, go to this address. Do you know if something useful will be there? Could it be garbage? You don't know. So it's just an address, nothing more, nothing less. What is this one doing? The new keyword?
Asking you for space on the heap.
It's asking.
Well,
You said you.
sorry.
I'm so picky in this class. It's asking who for space on the heap.
The operator.
Operating system. So is C++ getting the space on the heap? No, it's an operating system call. What does this mean?
It's creating the size of the array.
It's really creating the amount of space to set aside. How big is an int? Normally 4 bytes. Array size, I think I declared it as a big. Did I not declare it? Oh, I asked the user. Give me an array size. So if the user gives me 1,000,000, and int is 4, the new keyword is being requested for 4 million bytes. Not 4,000,004 bytes. There's no extra header or footer. in that, kind of telling you the bounds. None of that. It's not like a C string. It's just straight, a bunch of ints, nothing more, nothing less. What does new return? An address. That makes sense. We have an address. This returns an address. You can only store an address in an address. Now the thing about addresses and pointers is that they work with arrays side by side. They're almost two sides of the same coin. And so what we did is we looked at the address, we looked at the 0th data, we wrote data into the 0th data, and then we looked to see if we got the data back out. But we had some fun with this before. Could I do this? Why? Why can I do that? Doesn't know how big it is. It just knows it's an address. It doesn't know if it's pointing to valid space at all. You can tell it to do pointer arithmetic and go back one int slot and retrieve or write data to that one spot back there. What could be in that spot? One slot back behind our array. Garbage, somebody else's data, who knows? Potentially sensitive information. You're writing beyond array bounds. Here I'm writing on it from the left side. Could I write to it? Will that be in bounds or out of bounds? How far out? Just one slot out of bounds on the right side. Right? Because arrays counts from 0. Here's the rule of thumb of counting. If you're counting by a collection number, such as an index number, a computer count always starts at 0, but humans count at 1. So if you try to figure out which counting system do I use, is it a count you're telling an application developer how big this array is? Start counting from 1. Are you working with arrays? Start counting from 0. So yes, this is out of bounds because I'm taking the human-based count and then applying it to an array. They don't match. All right. So that's where we left off. We were running out of time. I just did some work, loaded data in. But there's one important thing we did not do yet, and that's give the data back. What happens if I don't give the data back? It's a memory leak. Now, to be fair, it's a memory leak until the program closes, because the operating system, maybe I should draw this out for you. That was for my other class. Let me go to this. Is this where we were? No. Is that it? No. I'll just make a new page. Call this guy 2420. So if you have your program and it makes a bunch of requests in heap, let's say new, I want 40 bytes, 20 bytes, 100 bytes. The operating system will keep track and say, oh, well, this program, we'll call it program 1. Program 1 at this address, well, let's actually give it a real looking address, has 40 bytes. At this address, there's 20 bytes, and at this address, you get the idea, there's 100 bytes. So when the program 1 closes down, the operating system can say, oh, well, this program is done, but it had all this memory set aside that wasn't freed, so the operating system can give that memory back. Make sense? But can the operating system know how your program is using this memory while the program is running? No, the operating system has no knowledge if you're really using it or if you're done with it. So you have to give it back manually. And the way you do that is how? Now there are two kinds of deletes, and it's really annoying when you mix them and you don't realize it. There's a delete and a delete square bracket. Do you know the difference, which one to use? If you use new with square brackets, you delete with square brackets. If you use new without square brackets, you just delete plain. These are not fun error messages to debug. So we will delete with square brackets, like so. Now here's something fun. Can I still get to my data after I delete it? What does deleting do?
It just gives the,
Yeah, delete's kind of a misnomer. I wish they called it give back for someone else. Or something a little clearer to reclaim.
Does it deallocate the space?
It's technically deallocated in the sense that, yeah, the operating system can now use that space for somebody else. But when we hear delete in our human brains, we think it's gone through some kind of virtual shredder and it zeroes out everything and everything's wiped out of there. No, it's like if you bought a house that's just you have a garbage house. You trash it and then you just give it up and you give it to somebody else. Did you take care of it when you gave it up? No, you just transfer ownership. Maybe that's a better way of transfer ownership back to OS. Do you like that name better? But we have to use delete. So after we did our delete, what does ARR still hold in it? It still has the address. Can I still go back to the address even though we gave it back to the OS? If you give up a trashed house, can you go back to the trash house? Should you? Could you? Yes. Should you? No. So sometimes line 30 will work. We might still see 42. Sometimes the operating system is smart enough to realize that you gave it back and you shouldn't be going back there. Undefined behavior happens. Let's try it, see what I get. Oh, darn it, it's printing. Try this again. Access read violation. It does not like me going back to it. Wait a minute. Did it change? I've never seen this before. Did it change my value of ARR? No, it did? I gotta see this. The address is that with an end L. So before I delete, I want to know the address. After I delete, I want to know the address. We rerun the program. The address is that. After delete, it changed the address on me. I have never seen this behavior. I can tell you that I have worked with systems where it gave you the same address back, and I went to that address, and I still got my data for a long time, and it created some very hard to track bugs. Those are intermittent bugs, the kind where it works 1,000 times, but the next time it doesn't. How about this? I'm going to be sneaky. Int star copy. All right, now I'm going to have a copy of it. Make sense? Does that copy the entire array? What does it copy? The address. So, but the copy has, aha, not going to fool me. We'll try going there. Oh, you did fool me. Here's the address. I still have the address, but what happens if I go there? Is that 42 still there? No, something else went by and overwrote the 42 for me. Something else picked it up and used it. Did any of you try it on yours? If you tried it, some of you, especially, I've seen it more in Linux that you'll get your data, but I often get my data back. It's ghostly data. So the way you really fix this problem, anytime you have a delete, I would strongly recommend nulling it out. This is something I wish was part of the original C++ standard, that when you use delete, you don't get your address back anymore, it's gone. And the nice part is the setting ARR equal to null pointer is This is the one and only one address that you can explicitly put into ARR. So I'm saying, I'm sorry, I'm saying put a 0 in ARR. Null it out. I don't want to have this address. And this makes for a little bit clearer error messages, because then if you still try to use ARR after the fact, I'm having all sorts of new behavior that I've never seen before. Oh, I still have the copy. That's why. Go back to the original. ARR has been nulled out. Let's go to the null. Let's try to dereference this null address and go to it. Aha! That's what I wanted. Exception thrown. Read address violation. Array was null pointer. What does that mean? Can I go to that null pointer? A better way to say this in computer science terms, do you remember how the true way to get to data, or the other way to get to data, is to dereference your pointer to get to 0th spot? Remember that? You put the star in front of it, it dereferences the pointer, it goes to the address and gets you the data. Can I dereference a null pointer? No. In fact, there's a funny little joke about this. Let's see if I can find it. Yeah, this. Hold on, Mo.
Come on, you guys. There it is, right there in front of you the whole time. You're dereferencing a null pointer. Open your eyes. Come on.
I don't know what this is from, why it's there, but it cracks me up. Some wrestlers getting mad at him for dereferencing a null pointer. This is defensive programming. It's good. We want to do it. It helps us find our mistakes later. So anytime you use delete, do an AR equals null point, or just null pointer out your pointer itself. Let's see, where are we at here? We still have Manny online. Here's something fun. What would happen if I did this? Is that a bad idea? Yeah, I named it. Now it's a good idea, because it's been defined that way. No, I'm defining it as a bad idea. Why?
You're creating 10,000 arrays.
I'm creating 100,000 arrays of size 50 times 4 bytes each. Do I ever give those arrays back? I'm losing the pointer. Does the operating system know I've lost the pointer? No. I wouldn't recommend doing this on your computer. I know I have space for it, but if I just tack on a few more zeros, I've done this before. It's not fun. You go into your task manager, you watch your memory just grow and grow, and then you hit a point where you've used up all your RAM, and it's really hard to stop the program at that point. So, don't do it. Hey, we should do our first participation code of the day. Let's write it in green. Let's do a digit. Digit 5. 5 will be our first participation code. You got that? So write it down in your notes. The first participation digit of 6 digits will be a 5. All right. We can go in 2 directions now. I think you have enough knowledge. Do you feel comfortable making arrays dynamically on the heap? We can do something called shared pointers, which clean themselves up for you. Or we can do we should do unique pointers. That's better right now. We'll do unique pointers which clean themselves up. Or we can do 2-dimensional arrays. Which topic do you want to talk about first? Any exciting one that you want to learn? If you want to do unique pointers, raise your hand. If you want to do two-dimensional arrays and learn about those, raise your hand. Nobody. No one wants to challenge, huh? All right, so C++11 gave us some tricks that we can use. And this actually came from what's called the Boost library. If the STL library just doesn't give you enough, or C++ doesn't give you enough, there's this resource of other interesting tools called Boost. And a lot of Boost features end up rolling into the C++ standard. This was one of them. These are really objects that fake acting like pointers. And there's enough tricks and tools inside of these that, from your point of view, treat it as a pointer. But you need to understand that it still is an object, and you're going to have a little bit of overhead cost associated with it. Let me demonstrate one for you. We will. Oh, I have to first include memory to make this work. So up at the top, do an include memory. And then I'm going to do std, using std unique pointer. No, not an initialized copy. Unique pointer, and make unique. Those are the two tools I'll use. Just so I don't have to type std all the time. Is everything going okay? Either I have a really quiet class or I'm a perfect teacher.
Second.
It's not the second, I know that. No questions. I always hammer it in. Your tuition means you pay about $25 every class period. You pay good money to be able to ask at least one question if you want to. You can say, I pay $25 and I'm confused, so it's your job to help me out. All right, so we've got that. So the tools here, instead of, let's give you a quick review. C does malloc and free. The old C++ way was new delete, or new new data type square brackets and delete square brackets. But with shared pointers, you can also do make unique and nothing else. It does it for you. So let's do it. Let's make a new array. I'll call this unique array. It's got to be the unique pointer, and it's a templated data type. Templates allow us to say, I want this object and it holds the data type I tell you to hold. We'll describe this a lot more soon. But for now, just trust me. I just want a unique pointer holding int arrays. So this is how I say int arrays. Is equal to make unique int array how many, array size. Did I do this correct? I forgot the name of it.
Is this operating system?
It is not.
It's not. Okay.
Try downstairs.
Okay.
I got to give it a name. Unique array. That's what I was missing. There we go. Now that's a long line of code. If you want to, you can replace this with simply auto. And that's starting to get more encouraged in industry. Because you can't make a typo mistake, and whatever data type this returns is what auto will become by the compiler. Now the question, is unique array an object or a raw pointer? What is it? I did say it was an object. It is an object, but it will act like a pointer. What that means is I should be able to do this to it. The same kind of code that I did before. But instead of ARR, I'm going to call these unique array. That's the name of them. So for unique array, I can still do square bracket indexing, and it works. It knows how to do square bracket indexing. Does that make sense so far? Let's just see if this program works. Please give me an array size. We will give it an array size of 100. The first round is from the regular array. The second round is from the unique pointer. And you can see I'm getting the same behavior. The cool part about unique array, it is unique pointers are reference counted, or they're not, I should say they're carefully tracked. So when they go out of scope, they clean up the allocation for you. Because unique array is really an object holding a pointer, maybe I could draw it this way. The raw way is that you simply have some pointer that holds an address, and if you go to that address, you find your data. Correct? But in the unique pointer way, you really have some kind of an object which inside will have a pointer, and maybe also a size. This guy was 100. So because it's an object, because our thing called unique, we called it unique array, this object knows where the pointer is. It also knows the bounds. So when the object itself goes out of scope and calls its own destructor, the destructor can say, oh, hey, I was pointing to something. I should clean this up automatically for you. And when it goes out of scope, it can clean it up. Does that make sense so far? This is great. And to show you that it works, well, boy, is there a good way I could show you it works? No, because the moment it goes out of scope, I can't use it anymore. Do you remember my whole bad idea, good idea thing? Let's show you this. Bad idea. We'll call this auto unique, or boring idea now. Int array holding 50 items. Does that look similar to our previous example? It's no longer a bad idea, it is now just a boring idea. Why? I make an object, it goes out of scope at the curly brace, comes around, creates a new boring object, or unique object, unique pointer pointing to an object, who then goes out of scope. It's just constantly creating stuff, and then it's cleaning itself up over and over and over again. So all I did is just waste a bunch of computer time. No memory leak. Do you like that? There is also something called shared pointers. So they have a make shared approach, but the thing about shared pointers, they are reference counted. So they're very similar to unique pointers, except that they have one extra little number. How many copies of me are floating about? So in a shared pointer, remember how I did that copy array? Because I was trying to be sneaky, and I had a copy of the address. With shared pointers, if you tried the same thing, you can make a copy of the object, but it reference counts. And so if you make a copy, it goes from a count of 1 to a count of 2. If one of those objects destructs, it looks at its reference count and says, well, I still have a count that's available. I'm not going to clean up my data. If there's 10, nothing cleans up. If it goes down to 0, 10, 9, 8, 7, 6, 5, 4, all the way down to 1, it's okay, but at 0, it then initiates a cleanup. Does that concept make sense to you? Do I need to explain it more? All right. There's shared pointer. One thing that's oh boy, how do I describe this? I'll show it by example. Maybe you try to abuse unique pointers by saying, well, what happens if you make a copy of a unique pointer? Does that let me get around the rules? That way, one of them destructs, but I've still got another one, so I still have an address. Is that a good idea to do? Watch this. Let's make a copy of the object. There's a red line. Why is there a red line? It's a rather annoying error message. Long story short, there's something called a move constructor, which we'll get to later in the semester, and unique pointers refuse to be moved. You cannot copy. No, I gotta back up. There's a move constructor and there's a copy constructor. This is the copy constructor. Unique constructors refuse to be copied. This is good. It's defensive programming. Shared pointers, you can copy. Unique pointers, you cannot copy. There's another kind of pointer which we'll deal with, and it's sort of a pointer, but not really. Iterators. These are old. Anytime you say old, you have to drag it out to mock people with it. Anybody who's old in real life, you have to say old. They appreciate it. They are objects that act like pointers to data containers. And we'll see why this is needed down the road, but we're going to deal with so many data containers. It gets to be a pain to say, well, how do you walk through this? How do you iterate through this container of stuff? And iterators are a standard de facto way of saying, let us act like pointers, but we're really objects. But we've overloaded all the syntax to act like pointers, so you can go through this container as if we were a pointer. And we'll be doing iterator pretty heavily. Moral of the story that I wanted you to know is that there are raw pointers, and you can use raw pointers with malloc free or new and delete. There are unique pointers. There are shared pointers, and there are iterators. And those four tend to describe the four types of pointers that are commonly used in C++ today. Now, people have taken this whole pointer idea, this objects that act like pointers, and they've expanded into all sorts of interesting directions. For now, we're just going to work with these four. We should do a second participation code. What is a good digit? Someone tell me a number between 0 and 9.
7.
What?
7.
7 is our second participation code. You got it? Write it down, 7. Good, let's continue on here. Let's try something now. I've never tried it this order. I want to start describing for you the next homework assignment right away. And then we can start talking about how we solve it. So if I give you the idea, yeah, at first it's going to feel overwhelming. You don't know how to do it. But then I'm going to give you all the pieces. This first assignment, as much as I don't like to do it, I need to walk you through it. It's kind of like a review. You got to get some confidence. I give a lot more hand-holding than I like. So we're going to do a stacks and queues homework assignment. These are two very common data structures. They're commonly used throughout computer science. You've probably used them already. In real life, you use them. You may not realize it. Stacks are, the idea of a stack is that you can put data into a stack. You'll have, say, some top of the stack and some bottom of the stack. But you can't ever access stuff unless, you can't ever grab stuff at the bottom of the stack. You can only get stuff at the top of the stack. Have any of you ever been to a buffet, like Chuck-A-Rama, or, you know, like those spring-loaded plates? You know what I'm talking about? They have these plates that are, from your point of view, all you see is one plate. But what do you know is underneath? More and more and more plates, correct? How do you get to the second plate? You have to take the top one off to get to the second one. These are spring-loaded. Unfortunately, as much as I've tried, you can't give that spring a lot of tension and get a shower of plates. I wish it would happen. I don't care what would happen. It'd be a great story for the rest of my life. I'd pay the fine. What if you were insistent? You wanted the fifth plate. You didn't want plates 1 through 4, but you want the fifth plate. How could you do it? Take off plates 1 through 4, grab the fifth plate, then put 4 through 1 back on. That's a very common stack operation in computer science. Because of that, these things are often given the name, the last one in is, I'm sorry, I got it back up. The first one in no, I'm back. I'm going to blame my cold. It's really my fault, but I'm blaming the cold. The last in is the first out, which has, oh, I forgot I have a rainbow pen. LIFO. Queues are also these linear data structures, but these ones are the first one in is the first one out, or a FIFO. Make sense? This country correctly gained independence from UK partly because of its strange words for things. When we go to the store, we get in line. What does the crazy English call it? You get in a queue. I mean, that's a letter. No, it's 5 letters. Q-U-E-U-E. I know, no, it's... But they say you're queuing up. You go in a queue. One of the best, Barnes & Noble did something I loved. That they had a whole bunch of cash registers, but they had one queue or one line of people. Sometimes you see this when you have to buy books that, everybody puts off buying their books, textbooks to that day of. So they just give you one line, and that way you don't have to try to guess the cashier, guess the slow person. I'm terrible at when I'm shopping. I'm always judging people. She still uses a checkbook and she writes slowly. That person's going to have coupons. That person's going to ask for assistance. And I just judge and try to find the best one. And this is a judge-free way of doing it, is you just have one line and you just filter out work as needed. So queues are useful in that approach. The idea is that since A was the first one to get into the queue, A will be the first one to get out of the queue. E was the last one in the queue, E will be the last one to get out of the queue. Now, queues, you can put them in either order. You can get some out of the queue, then put some in, then take some out, and then put some in. You get the idea. It's just the basic concept needed here. Now, there are doubly ended queues. These ones bug me even more. I'm going to blame this also on the British. I don't know who's at fault here. Maybe if you like etymology, you can find it. These are called DEQUE. Do you know how you pronounce that? No, it's not DQ. It's DEC. I want to learn Spanish. I give up on this language. So you can have a doubly ended queue, which is basically a stack and a queue married together. You can pop or push from either end. Make sense so far? All right. We're going to deal with stacks and queues at the moment. Some common operations on stacks are push to put your data on, pop to get rid of data, and top to look at data. So push, you're pushing in some data. If top is retrieving the data, then you're going to have a return type. If pop is just getting rid of it, it's like saying, hey, take this plate and throw it in the garbage can, my spring-loaded plates. It would then have a void return type because you're not doing anything with it. You're just getting rid of it. Make sense? So it's common if you want to retrieve stuff, you top, then pop, then top, then pop. Sometimes these are merged into just a pop. The pop both returns and removes. Queues, you tend to have a push and a pop. Sometimes they'll call it pop front and push back, just to be clear what you're doing. If you have the doubly ended queue, you can have a push, pop back and push front. Sometimes you can also have a front and back to view. This is kind of like the top equivalent. Does that make sense? You want to just look at it, but you don't want to get rid of it. They tend to have capacity checkers, so you can call size and figure out how big is each one. Length sometimes also tells you the same thing. There's a lot of commonalities across languages and how these things are used. Our goal for the homework assignment is simply to implement a working stack and queue. Not too hard in practice. We could do a pop that returns everything and also tops it, or we could do a pop and top. Same thing with our queues. We could add a front and back if we wanted to. How, though, do you implement one of these guys? We know two data structures up to this point. Single variables, which isn't really a data structure, or an array of stuff. Should we make our queue a whole bunch of single variables? We actually go into our code and say int var1, int var2, all the way out to say like var999, and tell people, hey, this thing can do up to 10,000, and just write a whole bunch of if statements to say, all right, if we're at this point, go grab this variable. We could track it, it would work. I've seen people code this before in the 1400 class. Should we do it this way? No. So what's the only other option we have? Array. Can we make an array act like a queue? Suppose I want, no, let's do stack. Can I make this guy act like a stack? Suppose I say I want my array to have a capacity of 10. I initialize it to say, I'm going to pre-give it some room, pre-initialize it with some capacity. I want you to have 10. Okay? So we've got 10. Oh, did I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our index 0, and so on. All the way up to index 9, correct? Suppose I want a stack of ints. I still have garbage data here and here. Just be aware that does exist. You got to be careful with it. Suppose somebody wants to push in an int. They push in a 3. Then they want to push in another int. Then another. Then another. Then they want to pop an int out. And they want to pop an int out again. We should effectively be here, correct? How do we track that internally? Any ideas? What? What we're going to do is, a variable to keep track of where we are in the stack. And the beauty is that we are going to put this all inside of an object. We will have a pointer. This could be a unique pointer. It could be a regular raw pointer. But this is a pointer to some allocated space. But we have all this other room we can use in the object. We can keep track of its capacity. And on construction, in the constructor, we could have said it has a capacity of 10. What else? You said keep track of where we are. You want to call that a current pause? Cur position, cur index. Maybe cur index makes the most sense. And before we have anything in the stack, let's say we start over, what should cur index be initialized to? 0 sounds good. We should also have, and we don't quite have it yet, I need more room. No, wait, can the cur index represent a size? It might be able to. We might get away with this. All right, somebody puts in data, a 3. Then what? Should we change capacity? Should we change cur index? Yes. Now someone inserts a 7. What should happen? Change cur index. Then they do it again. Then what? Change cur index. Again. I'm sorry, I did one more. Then I changed it again. We're now at 4. Suppose the user wants to go and look at the top. Top should not change the stack in any way. Top simply looks. Do I go and retrieve for the user the array at index 4? Why not? Is my data right here? No. So what do I need to do? Retrieve the array at what index? At 3, because that's the top. So how do I do that? I know I'm making this sound simple. You're going to hate it when you have to code it. You take the cur index and you subtract 1. Should I actually change cur index to a 3? No. I just have to take the value, subtract 1, and I keep the cur index at 4. Let's say I want to pop. How do I get rid of the 2? Yes, in computer science, rarely do you actually delete something. Usually you just give it up. Remember my whole, I give up on you, or I'm giving it back to the operating system? You don't really zeroing out the stuff. It's the same idea here. Do I need to actually physically destroy the 2 some way? No, what's an easier way? It's like how some of you, maybe you broke up with your significant others in high school. I'll just forget about them. How about that? Send them a text. I'm done with you. That's it. It's easy. Breaking up simple. You see them, you just turn the other way. You act like they don't exist. We'll do the same thing here. I will act like that value of 2 doesn't exist by simply acting like it's not there. It's rather rude of us, but it's the most efficient way to go. So yes, this 2 is still here. Nothing got rid of it, but I'm going to write it like this because it's like, kind of like a ghostly 2. It's still there, but I want to act like it's not there. I can still go retrieve it, but I shouldn't. Now let's say somebody pushes something back in. They push in an 8. What should happen? At cur index, write my data of 8. Now that 2 is really gone. Something else took over its spot. All right, we're doing good so far. Any questions on this? Everything we'll deal with in this class is bounds checking or scenarios. It's very easy for computer science students to do the general scenario, the easy one. But you got to think about the error situations. When can problems occur? Can you find what's one potential problem, or when can we keep calling push indefinitely or pop indefinitely? Why not? When could you not call push forever? When it fills up. So how do you verify when it's filled up? Let's say you just stick a bunch of data in there. If I stick in a bunch of data, then my cur index will end up at 10. What if I try to push again at this point? How do I check before I actually do it?
If statement.
If what?
If current index is equal to capacity.
If current index is equal to capacity, you should not attempt to write it. Instead, you should yell at the user.
Spit out that much.
What's another scenario on popping? Pop if cur index is at 0. Make sense? So you do need to have some error scenarios here. All right, so you're getting some general idea, but you've never really coded anything like this. And if I tell you, hey, I've given you instructions, I've told you everything you need, I tell you, most of you won't be able to code it. So what we're going to do is an example that's somewhat similar in that I get to use similar syntax, but not that you can just copy and paste this for your assignment. I like to do something called a safe array, where I want to write an object that acts like an array but it knows its own size and it prevents out of bounds check or accesses. Sound fair? So I'd still like to do ARR 4 is equal to 8. Now if that's still in bounds, great. But if I try to access outside of bounds, I want this one to something to go wrong and say you should not do that. In order to get here, we're going to need to know 2 tricks. Number 1, we have to make our object act like a pointer. So we have to overload the square bracket. We want our object to know how to use the square bracket, so you have to overload the square bracket operator. The other thing is, I want this a safe array to hold any data type. It can hold ints, or doubles, or strings, or other safe arrays. To do that, we have to learn about templates. Sound fair? If we get this concept down, you will then have enough knowledge to be able to get the homework assignment started. Let's try it. Manny, did we answer your question from earlier? I didn't see your chat comment. Okay. So I'm going to clear out this code. This is not code worth saving. You've got it in the lecture video. I'm going to start over here. So let's say that the user wants to make some kind of a safe array. And what data type should it hold? You guys tell me. Ints, doubles, chars, strings. Let's make it just strings. Include string. Using std string. So I want to make a safe array of strings, and I'm going to make a new, I'll put this guy on the object on the stack by just calling it my object, and I will give it some initial capacity. Are you okay with the syntax as I show it up here on line 14? Here's the data type name, here's the class, here is the object identifier name, here's what I'm passing into its constructor. Is that okay with you guys? No one's confused by the syntax? I know you should have seen it for 2 semesters, but people forget stuff. Alright, the only thing I'm tacking on is saying that I want my class to have strings in it. You know what, let's turn off the templates for now. We'll make this work without templates, and then we'll put templates into it after. That makes more sense. Alright, so I said I need a class called SafeArray. Let's define it. And I said I need a constructor. We'll start with int. And then we then need to also store it in a capacity. All right, I'm a picky person with C++ for good reason. I said that capacity is an int. I can do better than int. What can I tack on to that int to make it better? Any ideas? Will I ever change the capacity? No. So I'm going to make it const. Should the capacity ever be negative? No. So what should I do? Unsigned. Likewise, this guy should be unsigned, but I cannot make this one const because I am going to change the data member. I would love a way for a language to, once you change a variable, to say from here on out, make it const. It doesn't work that way. We good with this so far? All right, so there's our class signature. I'm going to put down safe array destructor and put a question mark by it. We don't know if we need this yet. We're also going to need to point to an array of stuff. How do I have the object track an array of stuff? I've shown you this before. Let's apply it. Tell me what to type. Like this is important enough, we should do our third participation digit. Let's make the third participation digit a 4. You got that? Third participation digit is a 4. All right, let's go back to our question. How do I make the object hold an array? Tell me what to type. It's a new technology. It's whatever you speak magically types on the screen. So you want what?
So we do a pointer.
A pointer. So I got pointer. I need more than that. What? A string pointer, because I wanted to point to strings. Then what?
Name.
What?
Name.
What name do you want to call it? Is ARR fine? You can also act like a pirate every time you say it. All right, anything else we need? Should I do int array 10 right here? No. I want this to be runtime based. If I start trying to define a size now, that causes all sorts of problems. Also, it's bad syntax as is. Should I do this? No, you should not run code in a definition. So we just want this much, but there's something else we can do a little bit better. C++11 gives us a new feature. Before, these things are initialized, and it gives you space, and whatever's in that space you get. So ARR will have a garbage address. But defensive programming says you never want garbage addresses. That's scary and dangerous. I would love this array to be immediately null pointered. Can I initialize variables to a value in C++11? Yes. It looks it's funny looking syntax, but this is how you do it. Square bracket, what you want to initialize it to. That's not running code. That is simply saying, when the object is created, ARR should have null pointer in it. Same thing with capacity. Should I let capacity be initialized to something that I don't want? No, so what could I do here?
Write it as 0.
And put a 0 in there? Yes. If you want to shorthand it, some data types have a default value. So if you don't specify a value, it will do the correct one for you. Ints have a default value of 0. Is this making sense so far? All right. So we've got the structure set up. We're doing okay. The first thing we should do is, let's not do overloading operator overloading just yet. Let's do something like this. My object dot add at index 0. Let's add some number. Sound fair? I'm just trying to show you. For me, whenever I try to design a class or an object, I act like I already have it defined and I start trying to use it in main. That tells me how to write the class later. So I want an add method. Sound fair? All right, so let's do this definition. Should this add method be public or private? Public. Its name is add. It's an add method. What else should I add to this method? 2 parameters. What's the first parameter's data type? What's the 0? It's an index. So what should be the data type of the index? Int, I can do better. Should indexes ever be negative? No. Will I ever want to change the index the user gave me? No. There's my first parameter. What's this one? That 100, is that an index? Oh, I'm sorry, I shouldn't have done index. This is a safe array of strings, isn't it? Pet name. I like pet names. Who's got a pet here? Give me your pet name. Anybody? Someone's got a pet.
Bo.
Bo. How do you spell it?
B-E-A-N.
What kind of animal is Bo?
Dog.
Dog. All right, we're adding Bo into index 0. Sound fair? All right, what is the data type? Or what do I need to put here for the second parameter's data type? String. Can I do better? I know Is anybody annoyed at C++ already? Like, dang it, I just want to program. I don't want to give you all these exactness. Yes, we can still do better, and we need to do better. Will we ever change bow, the string value? So what should I do? Const. Can I do better? What?
Unsigned.
Do what?
You can do unsigned, can't you?
There's no such thing as an unsigned string. That doesn't make any sense. You don't have negative strings.
Yeah,
Well, so what can we do? There's one really important thing, and it's not obvious. I wish the 1410 instructors cram this into your head, but they don't. There's by value copies and by reference copies. And soon there will also be a, is it called move copy? I forget the name of the third one. It's a newer one. You students haven't seen it yet, but I like to do it in this class. For now, let's do the first two. If I just give it a name, item, is this a by value or a by reference? When bow is being passed in, is it being passed in by value or by reference?
Right, bye.
By value, how do you know that?
Doesn't.
It doesn't have the thing that makes it by reference. What happens in a by value process? This is really important for CS students to know.
Creates a copy.
It makes a copy. It invokes, C++ will have a default copy constructor if you don't supply one, and it will attempt to do the copying for you. And that copying, sometimes it's so fast you don't care about it. Sometimes, let's say that the name of your pet, you're some psychopath, and instead of a 4-name dog, you give this dog a billion-character name. And you get furious with anybody who doesn't properly address your dog the right way. Should we do a by value copy of 1 billion characters? Maybe we can get away with it. For a lot of people, you won't notice the difference. But what's going to happen under the hood? It's a lot of work to process. It's got to set aside a bunch of stuff. It's got to copy all the ones from the old to the new and bring it on in just to get it in there. Did that seem needlessly wasteful? Yes. So how do we avoid unnecessary copies? By reference. This is a C++ feature. C doesn't have it. Makes life nice. I remember when I was a student, I got way too confused and upset by the by reference. I wanted to know what was going on and why. Don't let it confuse you too much. This is a magical compiler trick. It doesn't do a pointer to the thing. It doesn't rewrite your code for you. It's simply the compiler saying, I know what the true reference is, so I'm just going to compile the true reference in the actual code. So there's no copies at all. Just a compiler thing. We okay with that? All right, so we got this good, we got this good. I want to add the item to the index. So now we have to, oh, we forgot one other thing. A return type is missing. I can't just say add, I have to, all functions returns something. What's add returning? Nothing. So what do I say for add if it returns nothing? Void. Good, 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 good. Now I have provided the declaration to the add method. I have not provided the definition to it yet. C++, you put the declaration in one spot, you put the definition somewhere else. You don't have to, but this is better practice. So we say void is the method name. You can't just say add, you have to say where add belongs. Add belongs inside of safe array, and it has this signature, which I will copy and paste. Bam. How do I put item in the array at that index. This is the meat. This is the part where your whole idea comes together. The all-important line of code. What do I type? Stare at it hard because your assignment will make you do similar things.
You can do two ways. You can do R, brackets,
R, ARR, square brackets. Then what?
index,
Index
equals
equals
item.
item. That's the way we're going to do it. So in the array, add index, write the item. I think this is important enough that we should have another participation digit. How about a 3? Our fourth participation digit is a 3. All right, there's the fourth participation digit. Let's continue on. All right, that was pretty good. There's a couple of problems. I forgot one. First problem is this is the general scenario, but I don't have the error scenarios. The other problem is I never allocated array. Which one of these do you want to tackle first? Let's cover the error scenarios. Our mind is wrapped in that right now. All right, so what would be a problem? What are all the ways that this can screw up?
Index.
Index is out of bounds. How do I know if the index is out of bounds? If what? If index, if you're not sure, work it out on paper. I always do this all the time. If I can't figure out the errors in my mind, make yourself a little object on paper. Let's say that this guy has 5. Make it cleaner looking. An array of 5 slots. My indexes or indices are 0, 1, 2. I'm just offsetting them so they can fit easier here. 0, 1, 2, 3, 4. The capacity is 5. So what would be a bad index to try to write to? 5 would be a bad index. How do I generalize that to code? If index is what? Greater than or equal to. You gotta ask yourself. Don't just be satisfied with the greater. Ask yourself the equals as well. If index is 5 and my capacity is 5, is that a problem in that picture? Yes. For that reason, we have to do an equals here. You got it? So if it's out of bounds, what should I do?
Give a message.
There's, for here, I will actually do a cout. There's a C error, but I'll just do cout here. Cout. Index is out of bounds. And I will simply return. That return is important. I don't want to yell at the user and then try to write to the out of bounds. You need to bail out. All right. Is it possible the index could ever be negative? Why not? I set it to unsigned. What if the user supplies a negative anyways? Do you know what happens? It treats it as an unsigned, and it turns out it actually wraps around to a very large number. A -1 will wrap around to 4.2 billion something. So it'll take care of it anyways, and it's the user's own fault. All right, I think we got the error scenario handled. We got this going, we got this going. We're doing good. We have to get the constructor in place. So let's make our constructor. We forgot about that guy. Safe array. Everything has to match. Good. Right, what should go in here? It's a constructor. What do I need to do? Usually the constructor needs to load the data members. Does capacity need to be loaded with anything? Yes. Right now it's 0. How do I get this capacity to have that capacity? Is it even legal to have two capacities? Sure it is. So how do I say I want the capacity to have the capacity? You know the ones. It would be nice if you could tell the compiler, use your common sense. And fortunately for us, it color codes it on the screen. These capacities are the parameter. None of them are the data member. So how do I refer to the data member capacity? It is this. Hey, look, it turned white, just like the data member. Any questions on this? Hopefully they covered it for you. Questions on it? We okay? This class is surprisingly quiet. It worries me. I know there's somebody confused. Somebody's not... I don't want to ask a question. I don't want to be that guy. It's like taking the last food, you know, like a whole tray of cookies. There's one left. No one ever wants to eat that one because you don't want to be that person. Seems like there's always a trouble asking a question in class. Well, no one's done it yet. I don't want to break the mood in the class. No questions? We're okay with this? All right. Am I done with the constructor? What do I need to do? I still need the array, because right now it's null pointer. We've come to a fork in the road. Would you like this? At the moment, I've treated it like a raw array. Do you want to do raw arrays for the first assignment, or do you want to do this as a unique array? What do you guys prefer? Raw? All right, raw it is. How do I load the array? Tell me what I should type.
Need the memory address.
Tell me what to type. Tell me anything you know should show up in this line of code.
No, there's going to be an asterisk.
There'll be an asterisk in there? Okay. Keep going.
R,
What?
R,
ARR? Keep going. Equals new.
Is this a string array?
It is a string array.
String star be at the beginning. Or string asterisk.
Do I need a string asterisk here?
No, at the beginning.
At the beginning where? Here? Oh, here you say.
Yeah.
Okay, keep going. What? Square bracket. Capacity. It doesn't matter, they're the same capacity. Almost. You committed a cardinal sin. Something, there's heresy here. If we have a religion of computer science, I'd call you heretics. Something went terribly wrong. Do you see what it is? Capacity has been given a value. It's whatever the user gave us. That's okay. It is not that. It has nothing to do with capacity. What? ARR is already defined. But guess what this is doing? It's creating a second. Hold on. We're creating a local variable. This ARR scope lives and dies starting at this point, and it dies at that point. What happens to the data members ARR? Does it ever get used? So this is a problematic because in your point of view, you think, well, hey, it worked. I allocated the array. I look at the address. There is an address. But what's the issue? You lose track of the address. Meanwhile, this guy is still null pointer, and you don't have your array anymore. So how do we fix our cardinal sin?
You said this,
You either say this ARR, so now it refers to the data member. That's nice and clear and explicit. But if there's no confusion, you don't have to say this. If there's only one thing, then compiler says, oh yeah, ARR. Well, there's only one choice. It's got to be that one. Some programmers will say this to every single data member. It does get kind of annoying. But for shorthand, you can just say ARR. You got it?
why couldn't we do that with capacity?
Because there were two capacities. There's a parameter capacity and a data member capacity. Oh, you right here? Is that what you were asking?
No, I was asking before.
There were two capacities, so you have to explicitly say which one is which. If there's two, then it defaults to the local one first, and then only if there's ever a conflict, the local one wins. So we had to say this on the data member to refer to that guy. I kind of wish if I ever get to design a language, if there's ever a naming conflict, I would have this and that, just for fun. Yes?
I know to keep that straight in my mind when I was like setting up my code, I would always say like user entered capacity or something.
Yeah, sometimes you can do that. Like people will do like an underscore here, say, oh, it's underscore. That's secret stuff. Don't touch it. Or you try to have a second name,
User.
and then that way you don't confuse the two. I wouldn't recommend that. I don't, because it leads to more confusing code overall. You have to come up with some second name, and you have some weird system. Just use this.
Okay.
This keyword is here for a reason. All right, our constructor's good. But we used the new keyword, so we now created a new problem. What did we do? Destructor. There's a new, but we need the delete. So we do need a destructor. If we had chosen unique pointer, you wouldn't have needed a destructor. But we chose raw. So we need a destructor. What should go in our destructor? If the array is something valid, well, it turns out it'll always be something valid because I always constructed it. You could say that if you want to. I'm not going to. How do I clean it up? How do you deallocate it?
Brackets.
Yes, don't forget the brackets. And then what? ARR. Anything else we need to do? Do I need to set capacity to 0? Why not?
It's default one.
It initializes it 0 2.
But we set it to 10 or whatever we ask the user. Don't we need to set it back to 0? Why not?
It's the same principle.
It's being destructed. It's going to go away. Imagine you're exploding the thing. The idea here is that I want to get rid of this. And when it gets rid of it, it'll get rid of everything in it. It won't get rid of stuff it's pointing to unless you explicitly say, delete this thing. So if I change this from a 5 back to 0 and then it blows up, does that change anything? No. So for that reason, I don't have to set capacity to 0. I don't have to set array to null pointer because the object is going away anyways. So our destructor is done. How are we doing? All right, at this point, I'm violating one of my cardinal sins of writing a whole ton of code and not debugging it. So we should debug this now. I'm going to put a breakpoint on my line 47. Let's put a breakpoint on 46. Why not? I'm going to run my program. Good, no compiler errors. The breakpoint, the little yellow arrow, says that I am ready to call the constructor. So where did my step in 2 go? Is it smaller? Oh, it got collapsed on me. Manny, I'm going to ignore you for a bit. There we go. Step into, step over, step out. There's hotkeys as well if I want to use them. I want to go into the constructor, so I will step into. Where am I? The constructor. Do I need to continue to step into? No, I can go run the line of code. I'm not calling a function. It turns out, though, that these little initializers kind of act like a pre-constructor. So see how it brought the yellow arrow up there? Get the capacity to 0, because right now it is 10. Now it is still 10. I guess it learned. I don't know what it did there. The array is at null pointer. Good. Set the capacity 10 to 10. Good. ARR is null, but I want to allocate. If I do a step in 2 here, oh, it didn't do it. Sometimes it would take me into the new keyword call, and I could see how it allocates. Here it just allocated. So now I've got an address on the array. That's good. I can't see the stuff. It's just a pointer. But I know it's an array of 10. It comes out here. Let's call add. So I will step in 2. Step over. Is index 0 greater than capacity of 10? No. Step over. So it will assign bow into array at 0. I can see if it worked by highlighting this, and it will actually go and grab the array at 0, which is bow. I feel confident. My program's doing what it should. Step over, I'm good. All right. We have a tiny bit of time left. Let's do a get method. At index 0 is my object dot get 0. That's my goal here. Get that get method to work. Help me write the signature for the get method. Up above. Should get be public or private? Public. We have a method called get. What will be its return type? String. How many arguments were we passing in? 1. What was it? An index. So what should I put for the index data type? Const unsigned int index. There's one more thing that's going to annoy you, but I love annoying you. I'm going to throw another const on here. I love const. Const should be the default in C++, in my opinion. Everything should be const. I named my firstborn const. Why am I throwing a const here? What does that mean? Have you ever seen that before? What it means is the method is const. Meaning get cannot change or mutate the object. That kind of makes sense. I'm just getting data. The act of getting data shouldn't change anything. This is defensive programming. It also helps the compiler. It helps the user. It's a guideline to say that if the user knows that he can call get and it won't change the object, the compiler knows it. We will help ourselves later down the road so we can't accidentally modify it. What it technically means, for those of you who really want to know, the compiler secretly adds a secret little this key parameter on all your method calls, and it doesn't tell you. That's where the this pointer comes from. And the const makes the pointer constant. Since you don't have ability to make the pointer constant, you have nowhere else to put it, so they just shove it after. All right, we've got our get method. Let's put it in here below. The return type was string. The method was safe array. The name of the class was safe array. The name of the method was get. It had an unsigned, const unsigned int index. The method was const. All right, we write this, we go home for the day. It's motivation. You can leave now. I am not stopping you. Can't. But you feel better about leaving. Tell me, how do we write this?
We do validation check again first.
Yes, in my class, you should always handle specific error scenarios. Here's the best way to do it. Error scenarios, specific scenarios. There will be 2 more coming up for 2 more participation digits. General scenarios, in that order. And I want to hammer this in your head. Forget, there isn't a specific scenario, but there is an error scenario. So let's do the error scenario first. What's a bad case for an error scenario? What if the user asks for an index that's not valid? How do I check for that? If what? All right, if index is greater than or equal to capacity, then what? I can still say the error is out of bounds, but we need to stop our code right here. But that's a paradox, because we insisted we would return a string. But I don't have a string to return, so what should I do? To return some garbage string? No, we can do better than that. You say return an empty string, we can do better than that, because soon we're going to have to templatize this and generalize it. Nope, return null, because null is actually a data type. Anyone remember their error handling?
Catch,
Try, catch, throw. We're going to throw something. Throw's like the ejector seat of programs. You're not doing things the right way. You're trying to bail out of there. I'm not going to return anything. I'm getting out of this thing. The user can have a catch to see if something was thrown, but this is the only way to get out. Well, there's another way. You can bail out of the whole program. Crash the program. We're not going to do that. All right, so we've got our general scenario, or error scenario done. Let's write the general scenario. What should I return here? Return what?
index.
ARR at index. Let's run our whole program. I bet we'll get Bo back. At index 0 is Bo. All right, so we started to write some safe array, some basics of the safe array. What's an evil pet name? What's a kind of pet that you should not have, or a pet name? Someone be creative here. What was the ghost on the final boss ghost on Ghostbusters? What was that chick's name? Zool. There we go. I'm going to try to add Zool. Should I be able to get it? Blair, that's a good one too. Index is out of bounds. So I'm starting to get some bounds checking into this thing. It knows its own count. What we still have remaining is generalizing this with templates, adding in square bracket overloads. And then I need to go over tricks to solve the queue or stack and tricks to solve the queue. It doesn't seem right for me to just cram the assignment out the door. I really needed another hour to describe everything. So let's give you 2 more participation digits. You guys yell out, what's the last 2 participation digits? Need more digits.
4.
4, one more. 9. 9. Those are our last 2 participation digits. The other 4 participation digits were scattered about earlier in the lecture video. But I do want to give you a quiz today. This is the first of many quizzes. It's just a review quiz. Again, as I talked about, you don't get credit till you get 100%, but you can take it as many times as you want, as long as you want, wherever you want, up for a week. It'll close next Wednesday. If you get stuck, ask me in class. But that's just to help you review concepts and learn new concepts. All right, any other questions for me? All right, I will get the lecture video posted tonight, and I will see you Monday.